Hey, Harvey.
Hello, Anna. How you doing?
Fine. How are you doing?
I am doing well. So there's this little menu thing that says leave me.
Hello, everyone. It's so nice to actually see a few live faces out there. Know that people are still in the world. They're not just white names on black screens or virtual avatars that don't exist. I don't know. I could never tell whether one should watch the live presentation because that's really there, or watch the recordings. You can skip over all the intro, but it feels like it's somehow less real. I don't know. We need Paul Bloom or someone to tell us whether it's the essence of the video is there if you actually watch the recording, or if it misses some key thing like the sweat on Hitler's t-shirt or whatever is missing from the essence of presence. I don't know. I'm not an essentialist. I'm not qualified to comment.
As long as you don't wash the recording before you watch the recording, then I think
it's okay. It still maintains Harvey's sweat, so it's actually real and authentic. And
exactly.
Is a true recording and not a copy. I do miss the chatting before it starts. There's really no non-awkward way, right? You have to.
Except I'll say hi, Ken. Good to see you. Thanks for coming. Rob Derubis.
Hi, Rob. Great to see you. Great to see you all.
Kent, it's Harvey, are you going to say when Kent got his degree?
I sure am.
Okay, and I won't ask.
The introduction will happen. We'll get there.
Yeah. No, I just had that one question, but I'll hold on to it.
Well, given how excited everyone is for the introduction, let alone the talk, this is probably a good time to go ahead and get started. So I do not have the pleasure of introducing today's speaker, but I do have the pleasure of reminding you that there will be a virtual reception after the talk on GatherTown. I have put the link in the chat, and I will do so again at the end of the talk if the chat gets inundated with other comments and it gets lost. So that is all from me. I'm going to turn it over to Harvey, who will introduce our speaker.
Okay, so it's truly a joy for me to introduce today's speaker, Kent Berridge. Kent arrived, in answer to Rob's question, to Penn Psychology in 1979 to begin doctoral work after completing his bachelor's degree with honors from UC Davis. He was my first graduate student, and what a student he was. Very productive, intellectually generative, a gifted writer, and quite an independent person. He published his first data paper in his first year, and together we published 6 data papers and a major review before Kent left for a postdoc. The work revolved around measuring taste-driven affective responses in the context of learning and changes in physiology. In 1983, that was a 4-year PhD, Kent went to Dalhousie University in Nova Scotia to work with John Fentress on behavior pattern analysis and topics in neuroethology. And in 1985, after 2 years with John Fentress in Dalhousie, Kent went to the University of Michigan to begin a time there that has persisted up until the present, rising through the ranks. His position, his title is currently the James Olds Distinguished Professor. And there may be some here that know who James Olds was and many who don't. James Olds was a University of Michigan professor who was the discoverer of brain stimulation reward, a phenomena that provided insight into the neurobiology of reward, and a topic that is among several that Kent has pursued throughout his own career. In addition, Olds was the PhD mentor of Ralph Norgren, a colleague and co-author of Kent's and my postdoctoral advisor. Kent has had a remarkably productive career, both with respect to generating primary data publications, training graduate students and postdocs, and in addition, he's been prolific in generating reviews on a range of topics that connect to motivation and its neurobiologic underpinnings, and they have been cited many thousands of times. Among them, the debate over dopamine's role in reward, the case for incentive salience, motivation concepts in behavioral neuroscience, affective neuroscience of pleasure and reward in humans and animals, the neuroscience of natural rewards, relevance to addictive drugs, food reward, brain substrates of wanting and liking, and with Terry Robinson, the neural basis of drug craving and incentive sensitization theory of addiction, and what is the role of dopamine in reward, hedonic impact, reward learning, or incentive salience. Kent has been the recipient of numerous awards, among them the APA Distinguished Scientific Early Career Award, the APA Master Lecturer Award, the Guggenheim Fellow, the Faculty of 1,000 Faculty Member of the Year Award in Neuroscience in years 2011, 2012, 2016, and 2018. And with Terry Robinson, the Grauermeyer Award in Psychology, and the APA Distinguished Scientific Contributions Award. The title of Kent's talk for today is, very Kent-like, Delight, Desire, and Dread. Kent?
Thank you, Harvey, for that very, very kind introduction. I'd like to start by saying that I just have such very fond and positive memories of my time at Penn. So it's just such a pleasure for me to be with you today. I'm grateful to the Zoom technology that lets this happen. I couldn't have asked for a better mentor, graduate mentor, than Harvey Grill, who was just enormously supportive when I was at Penn. But also the department as a whole and Penn as a whole just was a marvelous way to begin. And for those of you who last fall saw the colloquium that did the history of the Penn Psychology Department with marvelous talks by Paul Rosin and Marty Seligman, and then many testimonials from alumni and former faculty and former students, just the testimonials of their fondness for Penn. I absolutely share that. And it's really clear that Penn has a special place in so many people's hearts who were once there. For me, it comes down to, I think, Penn was the first place where I really began to see psychology as a unified or possibly unified field, not just disparate areas in different topics, but with interest across. I think it was the colloquium and the faculty interaction at that time that made me feel that way, along with the prosems. Also, Penn was just an enormously supportive department for graduate students, and I'm sure that still is the case. And last, Penn seemed to have a propensity to try to sort out ideas and phenomena that were important from those that were maybe a little bit less important. There's beauty in all kinds of science, but Penn was always interested in trying to find important things in psychology and neuroscience, and I think that was a major theme and a great launch pad, and I'm sure is still today. So I'm just so grateful to you all and to Penn. Am I sharing the screen?
Yes, you are.
You are, okay, super then. So I want to talk today about delight, desire, and dread, and you'll see there are some definite Penn influences here. Basically, I'm going to talk about the notion that for delight and desire, you can distinguish between delight and desire, that there's a massive brain system for wanting mesolimbic dopamine and many other targets for wanting various rewards and things in life, but a rather tiny and fragile network for actual delight, for pleasure liking, that's reluctant to come on, that's easily disrupted, and possibly a reason why pleasures in life, intense pleasures are fewer and further between than intense desires in life, sometimes with pathological consequences. We'll see. Today, I'd like to really kind of do three things related to this theme of liking versus wanting. We'll also talk about the relation of desire to dread, of wanting to fear, a kind of counterintuitive relation that nonetheless, I think, exists kind of palpably and is very interesting psychologically. I'll do three things today. That's my intention. First, to give you a little sense of how we got here, the notion of liking versus wanting, why we think it's different now. I never thought so in the beginning, but now I do, why liking and wanting might be different. And to maybe give you a sense of something new, something old, but something new. And one of our newest demonstrations of the separation of wanting from liking is that it's possible to have intense wanting for what hurts, using the same incentive systems that make wanting for sugars, for cocaine, for other positive things in life, wanting for what hurts. It has no pleasure-liking component at all. It's kind of a proof of principle for the distinction, but also relevant to things like addictions and possibly things like self-harming behavior. And then last, look at clinical applications that they're not being made by me, but they're applications of the liking wanting distinction that are being made by many other people to human addictions and to other things like to anhedonia in depression and other disorders, and to things like paranoia as well, the relation of desire to dread. So those are the missions of today. And I'll start here by saying, even 20 years ago, well, 20 years ago, I would have thought that what I can tell you today about the mesolimbic system of wanting versus liking, that would have applied to sensory pleasures, to foods, to drinks, to sex, to drugs, but wouldn't have applied, I would have thought 20 years ago, to human cognitive and moral pleasures, to things like music, aesthetics, to things like general well-being, that these brain systems would not be the mediators of those, and that it would be all cortically based for those higher pleasures. But I would have been wrong 20 years ago, I think, to think that. And 20 years of neuroimaging evidence has convinced me that the mesolimbic system that we'll talk about is not just for sensory rewards, but is also involved in higher order rewards of loving a spouse or a child, of music and art appreciation, even sustained well-being. And the reason for thinking this, some of the evidence came from Philadelphia. Here's studies by Anna Rose Childress and her colleagues sort of comparing sex and drugs and saying the same brain systems in cocaine addicts get elicited by these two sensory pleasures, sense and sex and drugs. But also studies at Montreal, Zatorian colleagues at McGill University, showing that music students who are giving their life to music, the aesthetic appreciation, and are asked to listen to the music that gives them their favorite chills, their favorite piece of music that gives them chills while they're in the neuroimaging scanner. What lights up surprisingly are things like their nucleus accumbens, not just cortical structures, but the nucleus accumbens that's lighting up to sex and drugs, also to the favorite music of music students who are going to give their life to music. And even things like positive well-being, the hedonic component, at least, of positive well-being. This is a study from Richie Davidson and his colleagues at Wisconsin, showing that as older adults rate their satisfaction in life, there's a correlation between their positive well-being rating and activations of all things, the nucleus accumbens. I would never have expected that 20 years ago, but the evidence is saying that there may be a shared kind of system for these very different psychological pleasures. And the reason I'm stressing this at this moment is to say, what I'll tell you, the data that I can present comes mostly from, well, essentially all from sensory pleasures, largely from food and taste pleasures that began with Harvey Grill, also other sensory pleasures like drugs. But the issue is, what's the general applicability of the findings? And this kind of evidence is saying that what the mesolimbic system is telling us about one sensory pleasure may apply also in conclusions to other human higher level pleasures. And that's, I would say at this point, hypothesis A for me, that it's something that I think is probably likely true, and we'll watch the evidence continue to emerge. In any case, regardless of applicability, any pleasure, sensory or higher, can be broken into many different kinds of psychological components, some cognitive or associative, some conscious and some not necessarily, some having to do with motivation and others to do with actual pleasure core experiences. But we can simplify that diagram from a paper with Terry Robinson, my colleague, into just basically these three major categories of components shared by all rewards. There are things we like, the essence of a reward. There are things we usually want because we like them. And most of the things we want in life and like have some learning or expectation about them. So these three components are together, combined. I'm going to focus on liking and wanting, especially, and focus on their organization in the brain to see, although they usually come on together, they can come apart. They can be pulled apart in the laboratory, and there's a number of human conditions that may pull them apart as well that are of interest to psychologists. To give you a quick demonstration of the real distinctness of liking versus wanting, maybe I should show you something new, which is our proof of principle demonstration of wanting what hurts. Incentive wanting for what hurts. And to show you this is using a manipulation that activates the brain, optogenetics, using light and virus cells to stimulate and activate the brain. We're going to look at the activation of the amygdala to recruit the mesolimbic system. This is a situation in which a rat does not have to engage in any painful experience, but can if they wish to. This is a shock rod. If you touch this, the rat will get a shock. The rat does not have to touch it, could stay far away and never has to touch it. But an ordinary rat will touch it once, often twice, and then stay as far away as possible and show an anti-predator defensive reaction, fearful reaction towards this rod. What's the reaction that they show usually? Well, it's the same reaction that this mother ground squirrel in the California Sierra foothills is showing to this rattlesnake who's approaching her burrow. In the spring, the mother ground squirrel has pups in the burrow. The rattlesnake cannot eat the mother because it can't swallow the mother, but it could eat the pups if it can get into the burrow. And so the mother is defending her burrow, and she's showing this anti-predator defensive burying reaction towards the rattlesnake, kicking sand in the rattlesnake's face. And she may be joined by matrilineal sisters on either side, kicking sand. It's an evolved anti-predator reaction. Rats will show this same defensive, fearful reaction to the shock rod. So here's a rat who has buried this shock rod. That's what they do. Let's actually see this defensive reaction in a normal rat. And then what happens if we activate the mesolimbic system through the amygdala by pairing amygdala activations with encounters of the shock rod. Let's see what happens. This is a normal rat. Let's go back. Sorry about that. Let's make it play. There. A normal rat who she touches it for the very first time, got a shock, went away, touched a second time, that she'll never touch it again. She's staying as far away as possible now and starting to show a little bit of these defensive bearing reactions. Here's a amygdala laser rat, touches it, gets a shock for the first time, but comes back, seems very interested in this rod that just shocked her. And she's sniffing it and looking and holding back a little bit, gets another shock, and she'll do it again and again and again and get several shocks in several minutes and just be fascinated by this rod that's giving her pain. This is a fascination and incentive attraction. That's the contrast of the two rats. But I'm getting a little bit ahead of myself, this wanting what hurts, wanting separated from liking. We didn't discover the distinction of wanting from liking with optogenetics. It really goes back 30 years to the story of dopamine. My career has been filled with surprise after surprise after surprise, unexpected result, and disappointment after disappointment, really. Although sometimes there's a silver lining in the disappointment. And here's one that was a real disappointment at the time. It turned out okay in the end. I used to think that dopamine was pleasure liking. In the 1980s, most neuroscientists who studied reward thought that the mesolimbic dopamine system was pleasure liking. It was the major champion of this idea was Roy Wise, who was then at Concordia University in Montreal, who would write things like dopamine junctions represent a synaptic way station where sensory inputs are translated into the hedonic messages we experience as pleasure, euphoria, or yumminess. When I was a new assistant professor at Michigan, Roy was showing elegant experiment after experiment to suggest that, yes, this dopamine system seemed to be pleasure if you suppress the dopamine system and then gave rats sugars or cocaines or brain stimulation electrode rewards that Jamols discovered. The rats gradually ceased to respond to any of these rewards as though the pleasure had been drained away. Roy phoned me in my first years here at Michigan and said, you know, you're doing something that you started with Harvey Grill at University of Pennsylvania. You're looking at taste reactivity and liking reactions. I'm doing dopamine. Why don't we combine? Why don't we do a combined experiment? So he sent a graduate student down to Michigan from Montreal, and we did an experiment to look at pleasure liking of dopamine in a slightly different way. We were using Harvey Grill's measure of sweetness liking, which in a sense was related to Jacob Steiner's measure in human infants of sweetness liking and bitter disgust expressions, something that parents have done with infants for eons to ask their children, do you like the taste of the foods that we eat, by giving them small tastes. Here's a video from Jacob Steiner of a human infant on the first day of life who just got sugar water that was fast. Let's see it again. Sugar water droplet in the tongue. This is from Jacob Steiner in Israel, showing this relaxed face and tongue protrusions. Here's a Harvey Grill paradigm where a rat's getting sugar infusions into its mouth from above through painless oral cannula, and is showing these positive reactions, tongue protrusions and lateral tongue protrusions, licking of lips to this pleasant sucrose. This is bitterness from Jacob Steiner, scrunching of the face and eyes, gaping, triangular gapes of the mouth. And of course, rats don't scrunch their nose and eyes. They don't have the musculature, but they can gape, as Harvey Grill showed. They can flail their forelimbs. They can shake their heads to the bitterness. And it's sweetness versus bitterness, but it's not just sweetness versus bitterness. Because as Harvey had showed just before I came to Penn in the late 70s, when he was still with Ralph, if you take a sweet taste and you pair it with visceral illness several times to create a taste aversion, they respond to the sweet taste as though it were bitterness, like that. If you take a salty taste, like ocean water, as Harvey and I and Jay Shulkin showed in the early 80s, or even Dead Sea seawater, which is 3 times saltier than ocean water. It's a disgust reaction ordinarily, but if the rat wakes up in a sodium depleted state, they show the liking reactions, positive reactions to pleasantness versus disgust. It's not just sensory sweetness versus bitter. A number of brain manipulations will change the liking reaction. So we thought that dopamine would. With Roy Wise, we tried dopamine drugs. It failed to change the liking reactions. So with my colleague, Terry Robinson, we thought, well, let's do a stronger dopamine manipulation. Let's take away dopamine, which would leave all rewards without value by the dopamine pleasure hypothesis. And indeed, rats who've lost their dopamine systems, who've lost 98 to 99% of the dopamine, because they've had a small neurotoxic lesion using 6-hydroxydopamine that only killed dopamine neurons, they don't respond to any rewards. They don't eat or drink voluntarily. You have to maintain them, as Harvey does for the decerebrate rats, with artificial food and hydration. We thought that should change the liking reactions. So we gave these rats who had only 2% or less of their dopamine remaining sugar solutions, and they were basically the same in their positive liking reactions as normal rats. And they had no aversive disgust reactions to the sugar. But they could still change. They could still learn new values and alter their values. If we paired the sweet taste with nausea 3 times, lithium chloride injections, and then asked them, everybody, including the dopamine depleted rats, now showed completely aversive disgust reactions, and they had lost their positive liking reactions. So both normal liking of sweet tastes and the ability to learn new disliking and other new liking seemed still intact even after dopamine loss. This was the beginning of the notion that dopamine might not be pleasure liking after all. It seemed to be mediating the wanting for the rewards, but not the liking. Still, it's fair to say nobody believed us. I think in the 1990s, very few people believed us. It wasn't until 2000s, the years 2000 and later, that human evidence started to come along later, suggesting that the same conclusion was true in people when you could ask them about it. So here's an example from Marco Layton at McGill University, who gives people cocaine and asks them to rate it, whether they want it or whether they like it. And the thing about cocaine is that the higher the dose you take, this is higher and higher doses, the black line, the more cocaine you want. The higher the cocaine you get, the more you like the cocaine, and the more you like the cocaine, the more you want to take more cocaine. That's sort of a thing about cocaine. When you like it, you want to take more cocaine. But also in some people, he would deplete their dopamine, either with an amino acid kind of cocktail or with dopamine blocking drugs. And the question was, would this reduce the pleasure liking, the euphoria of cocaine? The answer was no, it didn't. There didn't seem to be any change. That's the red line here in their liking euphoria ratings of cocaine. But it did reduce their wanting to take more cocaine. In people, as well as rats, although the data was 10 years later or so, it seemed to be for both drugs and for foods, the same kind of experiments. Dopamine was involved more in wanting than in liking. This seems to be true for humans as an application as well as for rats. By wanting, I always put in quotation marks, I mean a particular psychological processing. It's not your wanting for world peace. It is your wanting for food and drink, for consumer items, for things that light up your mesolimbic system if you're in the scanner. These are things that obey particular rules. It's a process called incentive salience, and it obeys particular rules. They're triggered by cues. The rules were first described by Dalbert Bindra, a psychologist at McGill, and kind of elaborated, I think, nicely by Fred Totes in England. Cue-triggered motivation. Bindra argued that reward pairings, it doesn't just lead to predictions of rewards, and it's not about drives or drive reductions. It's that cues become motivational triggers and motivational magnets, the cues for their rewards. They gain incentive salience. It's hard not to notice a reward cue. It's hard not to pay attention. They become attractive motivational magnets. In animal studies, they may be even tried to consume the cue. The rat may eat up the metal cue or light cue, and cues become attractive to people. But the cues also trigger surges of wanting for their own rewards. If you're walking down the street and you're not particularly hungry, but you haven't had lunch and you suddenly smell food, it may trigger a desire to eat. It's a trigger, yet not always a trigger. Actually, when Bindra published his first paper, it was in a journal that allowed critiques, and one of the critiques was Randy Gallistel's. It was probably the only critique among them all that was actually a cogent critique. And Randy Gallistel said, well, cues can't be triggers of these motivations because they don't always work. He was saying that he got up from his Thanksgiving table, not wanting to see another turkey again in his life. But as he was writing his critique in early December, he anticipated having a turkey for Christmas, and he was ready for that noble bird. He was saying that cues vary in their motivational strengths. They're modulated by appetites. They're modulated by stress. They're modulated by whether you've taken a hit of cocaine or something else. They're modulated by brain states that all these things influence. If dopamine is wanting of this sort, there is an application, and not liking, there's an immediate application. While I was studying wanting versus liking, Terry Robinson, my colleague here at Michigan, was studying an effect of drugs of abuse on dopamine systems. Everybody knew that if you take drugs again and again, it would produce tolerance, it would produce withdrawal for some drugs. If you stop taking the drugs, those effects would go away. But Terry Robinson was also showing at that time in the 90s that for some individuals who are vulnerable, drugs of abuse can produce another kind of change that's more permanent, the opposite essentially of tolerance. It's called sensitization, neural sensitization of dopamine systems, where if you take the drug 10 times, on the 10th dose, it elicits a bigger surge of dopamine than it did the first time, the same dose. It doesn't happen in everyone. Some individuals are vulnerable due to genes and earlier life experiences and such. They develop this neural sensitization. It happens best if the drugs are taken in binges, separated, not continuously. If it happens, and if dopamine mediates wanting, then the notion was, if this ever happened in a person, it could produce sensitization of the dopamine wanting system, leading to wanting and wanting, even if the pleasure of drugs went down due to tolerance. There'd be this detachment, liking versus wanting. So this was the first application of the notion that wanting could be separated. And the thing about neural sensitization is, if it happens in an individual, it doesn't go away when the drug stops being taken for weeks or months. If anything, the sensitization strengthens over that period of abstinence, and it can last half a lifetime in a rat, that is a year or so. It can last at least years in a person, maybe half a lifetime. So this was an application. It's fair to say very few people believed this theory proposed in the mid-90s, but in the last 10 years, there have been more belief in it, perhaps partly due to a diabolical human experiment that's been carried out inadvertently by the discovery in the last 10 years or so of new medications for Parkinson's disease. The old medications you may know are things like L-Dopa, which helps neurons in the brain make natural dopamine. It's a precursor for dopamine, so neurons make natural dopamine. The new medications, starting about 10 years ago, are called direct agonist medications. They're like fake dopamine, artificial dopamine. They can directly plug into receptors, especially D2, D3 receptors for dopamine, but they don't need natural dopamine. They jump over it, they plug into the receptors. They help the symptoms of Parkinson's. But in about 15% of the patients, they also induce addiction-like compulsive motivations, sometimes compulsive gambling, even in people who never gambled before. Sometimes compulsive sex and pornography pursuit, sometimes compulsive shopping, sometimes compulsive binge eating, sometimes compulsive hobbies and punding, things like sorting buttons in a drawer. And often if a person shows one of these things, they might show a second or a third. So it's like a cluster of these addictive things in patients who are vulnerable. Why is it happening? Well, in the patients in which it happens, it seems they've become sensitized by their new medications. This is a neuroimaging PET study looking at dopamine release in the striatum and the nucleus accumbens ventral striatum. And you're seeing all these bars are Parkinson's patients who are getting a dose of L-DOPA, the same dose of L-DOPA, all Parkinson's patients. The red bars are patients, ordinary Parkinson's patients who don't have compulsive motivations. They surge in dopamine. The blue bars are dopamine release in patients who do have one of these compulsive motivations or more. And you can see they're showing greater dopamine release to the same dose of L-DOPA that is triggering moderate dopamine release in the other Parkinson's patients. This is a sensitization signature, this hyperreactivity of mesolimbic circuitry. And the authors concluded that as a result of neural sensitization in these vulnerable individuals, reward-related cues are attributed with a pathological incentive salience, leading to compulsive pursuit. Not an experiment that anyone would ever ethically approve, but inadvertently accomplished and very, very revealing. So all of that is about wanting in the brain, and it's fair to ask if dopamine isn't liking, but is only wanting, what is in the brain that generates true liking? Jim Olds discovered pleasure electrodes. They might have been wanting, they might have been liking, but what in the brain is actually true liking? Can we narrow it down? Well, even with our very limited methods, we can find true neural mechanisms that can cause intense pleasure liking. These little hedonic hotspots read here. As a circuit that interacts together. These hedonic hotspots, we call them because they are sites which, if we stimulate them in the right way, with opioid stimulation, with endocannabinoid, marijuana-like stimulation, with a few other neurochemicals, we can enhance liking reactions even with our relatively simple measure that I borrowed from Harvey Grill that he developed. These liking reactions will go up if we stimulate these hedonic hotspots. They're tiny zones within a structure, and they're fragile. They need to activate each other to create the liking enhancement, and only a few neurochemicals will cause the liking enhancement. Dopamine never causes it, even in a hedonic hotspot. There's a couple in the prefrontal cortex, the orbital frontal cortex and insula, then the nucleus accumbens and the ventral pallidum. To give you an example of what it looks like, here's a sagittal sideways slice of a rat brain. The nucleus accumbens is here. If we blow it up, this is the nucleus accumbens in sideways view, a slice through the medial shell. What you're seeing here, it looks a little bit like a neuroimaging scan, but it isn't. It's not measuring neural activations to a psychological cue. It's measuring neural causation of psychological consequences. Wherever you're seeing a splotch here that's green, each splotch is a microinjection of an opioid stimulating drug. We know the size of the splotch because we can see neurons light up and express phos, so we can see the size of splotch and measure it. But the color of the splotch tells us what it's doing psychologically. Wherever it's green, it's making the rats eat twice as much as usual, or 4 times as much as usual, or 8 times as much as usual at the darkest green. And the green fills the entire medial shell of the nucleus accumbens. It goes under the orange. It would come out into the room from your computer screen. It fills up the entire 3-dimensional nucleus accumbens. It spreads to parts of the neostriatum above and to other parts of the brain and the amygdala. There's a lot of green in the brain. The red splotches are where the opioid microinjection is also doing a second thing. It's doubling or tripling the liking reactions to the sugar. There's no a priori reason why all opioid liking sites should be clustered together in the nucleus accumbens. We thought they'd be distributed. There's no reason why they should be clustered, but They are clustered, and that cluster defines the hedonic hotspot. It is what is the hedonic hotspot. It's the part of the nucleus accumbens that's capable of enhancing liking as well as wanting. Elsewhere, opioids are a bit like dopamine. In the rest of the nucleus accumbens, they cause wanting, but not an enhancement of liking. In the cortex, there are hedonic hotspots too. Daniel Castro in my lab, who's now a postdoc at the University of Washington, mapped out the lateral surface of the cortex in the rat brain and the medial surface of the cortex, this anterior cingulate and medial orbital frontal, with microinjections of opioid stimulating drugs and orexin and others. And he found an opioid hedonic hotspot in the orbital frontal cortex. This is really one hedonic hotspot. The very front of the lateral surface merges together, wraps over into the medial front of the orbital frontal cortex. One hedonic hotspot in the very front of the orbital frontal cortex. Another hedonic hotspot in the posterior insula. And in between, there's even suppressive hedonic cold spots that suppress positive liking to sugar, even if they enhance wanting and other separations of liking and wanting. These hedonic hotspots will triple or more the liking reactions to a sweet taste. How do they do it? Well, whenever a microinjection, say in the orbital frontal cortex, enhances liking, it does so, this diagram is telling us, by recruiting the other hedonic hotspots. One hedonic hotspot recruits the rest into a unanimous circuit activation. We're seeing this as FOS expression being amplified in the nucleus accumbens hedonic hotspot, in the insula hedonic hotspot, in the ventral pallidum hotspot, all induced by a single microinjection in the orbital frontal hotspot. And the same thing works if you do a microinjection in the accumbens, it activates the others too. So hedonic hotspots can amplify liking reactions, doubling them, tripling them, quadrupling the liking reactions. They're fragile, they have to recruit each other. And if you disrupt that unanimous recruitment, you disrupt the enhancement of liking. And I believe this may be a reason, this fragility of the network is the reason why it's not so easy to create intense pleasures in life. It's relatively easy to create intense desires in life, different brain systems. And the very last thing I should say about hedonic hotspots is that these are all sort of gains of function in hedonic enhancements. What would happen if we took a hedonic hotspot away? Well, for many of them, not much. It doesn't really actually change liking reactions. It's not a loss of function. It's not reciprocal. But there is one hedonic hotspot, particularly the ventral pallidum hedonic hotspot, which if it's lesioned or inhibited, sweetness, liked things become disgusting. Sweetness becomes disgusting and elicits aversive reactions. There's only one site in the brain, I believe, where a single lesion, a localized lesion, or a localized inhibition converts nice things into nasty. And that site is this posterior ventral pallidum. It can both enhance liking and is necessary for his normal liking. A pen note, many years ago in the early 1960s, Phil Teitelbaum and Alan Epstein showed that this site, a similar site seemed to be the lateral hypothalamus. They did big electrolytic lesions, and Harvey Grill with Steve Fluharty years later followed up on this. Big lateral hypothalamic electrode lesions convert liking to disgust. But it turns out that the crucial damage is not the lateral hypothalamus right behind the ventral pallidum. It's only the ventral pallidum. If you lesion the lateral hypothalamus but leave the ventral pallidum, liking remains normal. It's something special. Whenever I say that there's only this one site in the brain that can convert liking to disgust if it's damaged, it feels that I ought to say something more. That has to be an important kind of insight into the hedonic organization of the brain. There's a story there that can be told, that needs to be told. I can't tell it, I don't know it, but there is a story there to be found out for why is that site is so especially important to normal liking. The new thing, psychology and neuroscience in addiction and motivation has a pretty good understanding of the control of the intensity of motivation to eat, to take drugs. But I don't think we have a good understanding of what controls the targeting and the focus of motivation. In normal life, when you're hungry, you want food. When you're thirsty, you want a drink. In a different mood, you want something else catches your eye. In addiction, one thing becomes especially wanted and kind of fixed, and other things might be relatively less wanted even than normal. What's controlling the focus, the direction, and the narrowness versus the breadth of focus that is important in normal motivation and especially salient in addictions? Here we go back to this optogenetic manipulation, we're targeting this as a way of getting control of the focus of motivation, and also to understand a little bit better the organization of valence. The brain isn't just made up of pleasure-labeled lines and desire-labeled lines versus fear or disgust. There is a sharing that has to be understood, and this is an attempt to get a handle on that. We're focused on the amygdala as an entry because the amygdala is kind of famous as a perceptual learning motivation interface. Going back to the Kluver-Bucy syndrome, deciding what it is to want, directing motivation, something about the amygdala in its interactions with the mesolimbic system is important. So this is why we're there. Let's look again, a closer look at what I showed you in the beginning, wanting what hurts. What is going on in the creation of wanting what hurts? We pair the laser activation of the amygdala with encounters of the shock rod. Whenever the rat gets within a centimeter of the shock rod voluntarily, the laser comes on. If it leaves it, the laser goes off. So it's paired with this encounter. It's going to recruit the mesolimbic system. Let's see it again a little bit more thoroughly. This is a normal rat with inactive virus in its amygdala. So it's getting laser, but there's no activation of its amygdala. And we're seeing fearful reactions to the shock rod. Here's an amygdala channel rhodopsin rat who's going to get actual neural stimulation from the laser in the amygdala. We can see she's fascinated again. These are female rats, but it will happen in males as well. This is a second female rat who's showing it. You can see she's eagerly, frenziedly even biting it. A different rat, all kinds of strains of rats, all kinds of both sexes of rats. It's a very robust phenomenon. 9 out of 10 or 10 out of 10 rats in this situation will show this behavior, this wanting. They're not just attacking the rod. They are motivated and attracted to the rod. And it's not that they want necessarily to be hurt. As you watch them, you don't see them throw themselves on the rod. Sometimes they'll hold the paw away, but they just can't resist interacting with the rod, and their nose or their mouth or their paw will touch. And in 5 minutes, they'll touch 5 times. In 10 minutes, they'll touch 10 times. We let them go up to 10 or so, and then we take them out. But I think they go on and shock and shock and shock and shock and again. They are attracted to that rod. They will work to obtain the rod if we protect them by moving them to the other side of a barrier, put a barrier in between, so they can't even see the rod. They don't have to go back. What will happen is these channel rhodopsin amygdala rats will cross the barrier 5 times in a 10-minute session, and every time they cross, they will touch the rod again. They're motivated to work to get to that rod. There's incentive salience features of this motivation. I've said that cues become attractive. I think the rod is essentially a cue that becomes attractive. They start to behave towards it as though it is an incentive. They not only are attracted, but you can see they were nibbling and biting and sniffing this thing. It was incredibly attractive. It's the rod that shocks them that becomes attractive. It's not just any rod. If you took a dummy rod that didn't shock them and paired amygdala activation with that, they're not attracted to that dummy rod. The fact that the rod shocks them is an element of their attraction interacting with this brain stimulation. As I said, I believe that an incentive salience process is going on, that it's a kind of a cue-triggered want, a cue-focused want. Why believe that? Well, the rod, in a sense, could be a cue, but here's a more potent bit of evidence. They also have another cue, a pure Pavlovian cue that's paired with these rod shocks. It's an auditory cue. Whenever they touch the rod and get a shock and get their amygdala activation, they hear a tone, beep, a Pavlovian conditioned stimulus paired with the shocks. We can ask a rat later, would you want to hear a shock that means sound? A sound that means shock to you? You can ask a rat, do you want to hear the sound that means shock that's associated with shock? You can ask it by putting it in a conditioned reinforcement test. There's no shocks, there's no rods. Just if you nose poke into this hole, you'll hear the sound that you heard when you got a shock. On a different day, this other hole is just an inactive measure of control. Do you want to explore? On another day, put them in, and if you poke in the hole, you'll hear a sound, a safe sound, a CS- sound that you've heard at home. Normal rats, the gray bars here, will work for the sound that they heard at home. Sure, I'll work for that sound. But a normal rat will not at all work, will avoid a shock-paired sound. They do not want to hear a shock-paired sound. Why would a rat want to hear a shock-paired sound? But the channel rhodopsin rats who were attracted to the rod, they do want to hear the shock-paired sound even more than they want to hear the home sound. They'll work many times to hear, give me the sound again, that shock sound again, that shock sound again. Please give me that shock sound again. This is incentive salience. The cue itself has become wanted and attractive. Why are the rats attracted to this rod? Well, here we're seeing the brain activation of a shock rod rat with the amygdala activation who was attracted to the rod. We're seeing the brain activation immediately after the rod attraction. We take them out of the rod attraction and we look at their brains and look at FOS expression in their brains and compare that to rats who were afraid of the rod, normal rats. So wherever you see it's red, it's doubling FOS activation, doubling neuronal activation expressed by FOS in the dopamine origins, the ventral tegmental area and the substantia nigra. In the nucleus accumbens, especially in the front part that contains the hedonic hotspot, in the orbital frontal cortex, in the part that had the hedonic hotspot, in the posterior insula that had a hedonic hotspot. It's activating the entire mesolimbic circuit that's to create the want for what hurts. If you were thinking that, well, maybe these rats just really wanted laser, it's not that they really want laser. Most of these rats will not self-stimulate. If you give them an innocuous object, say, touch this object, and you can get laser by itself, no shock. Most of the rats, even rats who are attracted to the shock rod, they don't work to self-stimulate their laser. One does here, but most of them are not working to self-stimulate any more than control rats who had no amygdala activation. These are not pleasure electrodes. They are not Jim and Old's electrode. For most of these rats, these are neutral, unless you put it on a shock rod, or if you put it on something nice. I don't think this is just about pathological wanting what hurts. I think this is also an element of addiction. We can take new rats and we can make rats either into a cocaine addict who ignore sugar or into a sugar addict who ignore cocaine. Let's see that. We'll take two groups of rats. One group of rats, if they poke their nose into this hole, they'll earn a cocaine infusion, intravenous cocaine infusion, painless, and laser activation of their amygdala. If they poke their nose into this hole, they'll earn a sugar pellet, but no laser activation. A different group of rats, if they poke their nose into this hole, they'll earn a sugar pellet plus laser activation. If they poke their nose into this hole, they'll earn cocaine infusion, but no laser activation. What happens? Well, what's it like? First, I'll show you the situation. Here's the situation for the rats. This nose poke comes out. If it pokes there, this rat now gets laser and sucrose with the sugar pellet. This is the pain infusion. It's painless. It's connected. It's protected by a wire outer ring. There's a rat who's looking for cocaine and laser. But what are the results? What are the results? Let's see the results. The group of rats who had the laser put on sugar work intensely for sugar, and they ignore intravenous cocaine. There's nothing magic about cocaine, even as an addictive, potentially addictive stimulus. These rats are becoming sugar addicts, but they don't care about cocaine. The other group who had the laser put on cocaine do become cocaine addicts, and they ignore sugar. If you're wondering what ordinary rats would do in this situation, well, they take some sugar and they take some cocaine. Why not? They can get both. They can take both. But you can create them into a narrowly focused cocaine addict who ignores sugar, or into a narrowly focused sugar addict who ignores cocaine at your whim if you have an amygdala laser. The amygdala laser is a sledgehammer, of course. It's creating this in the space of a week or 2 weeks. But a person who had endogenous activation in this circuit, paired with particular events, conceivably could, over time, develop the same narrow focus that we're creating so quickly with the sledgehammer. If you're wondering, does this laser, this amygdala laser that enhances wanting and focuses it, is it also making these things liked? Well, for cocaine and the shock rod, we can't really ask clearly whether they like those things more, but we can ask them for sugar. And if we take rats who have 2 sugars, and we pair laser with 1, these rats will narrowly focus, become addicts of only the laser paired sugar. They ignore the other sugar. We can then ask them in the Harvey-Grill technique, does the laser enhance the liking of the sugar that makes them want more using the taste reactivity technique? The answer is no. These are the positive liking reactions with the laser on or the laser off in the same rats. These are the individual rats. And you can see it does not enhance, the laser does not enhance the liking. It doesn't change the aversive reactions. It doesn't seem to change liking or disliking. It makes them simply want that. The last thing I'll say about this laser is that although it's creating these intense desires for cocaine, for sugar, and even shock rod, it can be flipped in valence and made to increase fear. This wanting system can turn into a dread system if we simply change the situation. If we switch to a psychological Pavlovian, traditional Pavlovian fear conditioning situation, such as Joe Ledoux and others have used for years to study Pavlovian fear conditioning, there a sound predicts unavoidable foot shock, inescapable foot shock. The universe is nasty in this situation. There's no avoiding this nasty thing, and the sound makes the rat freeze. If we pair the laser with this, what happens is the laser enhances the freezing, fearful reactions. Even in rats that has made it, that have the same laser has made attracted to a shock rod, in the Pavlovian shock situation, it enhances fear, not desire. And it enhances avoidance of another contextual fear CS, an odor that's been paired with a shock situation. It enhances their avoidance. So the same laser can create intensified fear or create intensified and narrowly focused desire, depending on how you use it, how to make sense of this. How can the same manipulation in the brain cause both wanting and fear? Well, both incentive salience, this mesolimbic wanting process, and fearful salience, which also can be induced by mesolimbic manipulations, even in the accumbens that I haven't told you about. They share not only this neural kind of underlying mechanism, but also psychological features, some psychological features. For instance, it's hard not to look at a cue for either fear or for either threat or reward. They're both attention grabbing. They both can activate this neural system, but the system can flip its modes, its valence modes, to be either fearful or wanting. And there are clinical implications of this we'll see in a moment. It can either create intensified fear or further intensify even maladaptive wants. Enough rat experiments. The very last thing I'll mention as I finish the talk are what are the human clinical applications of this sort of thing? Well, the optogenetic amygdala manipulations are new. We don't have specific ones, although there are implications that we can imagine that we can talk about. But the applications of the liking versus wanting distinction by now are actually many. The original one we said was drug addiction. That was the original application of liking versus wanting. There are many, many neuroimaging studies, including those by Anna Rose Childress, who show that cues for drugs activate the brain more intensely in addicts than in other individuals. And this one it's no accident, I think, that it's the amygdala that can be activated as well as striatal related circuitry. I said this theory was not believed originally, and I think it's fair, that's fair. And it certainly wasn't cited very much in its first 10 years of life or even 15 years of life. But in its last decade, it's been more cited, partly because of experimental evidence from these animals, partly because of human cocaine-like Marco-Layton sort of experiments, and partly because of the human Parkinson's patients who are becoming addicts with intense wants, but not intense likes because of their dopamine stimulating medications. In the last 10 years, the notion has been applied to behavioral addictions. If you had asked me 10 years ago, I would have thought incentive sensitization is an explanation potentially for drug addiction, but not behavioral addictions, and that behavioral addictions are not addictions in the same sense that drug addictions can be. The reason I would have said that is because we knew something about how drugs can sensitize dopamine neural systems, the mechanisms, cellular and molecular, involved. And how would you do that without drugs? Well, I should have remembered even then that there's always been evidence going back decades that you could sensitize mesolimbic systems without drugs, even in rats. Terry Robinson did it in the 1990s using stresses rather than drugs. Stresses, stressful experiences would sensitize dopamine systems in rats and cross-sensitize so that if you gave them an injection of drugs afterwards, they'd show a higher reaction to the drug. Cross-sensitization induced by stress. Well, the neuroimaging studies in the last 10 years, well, this is just showing incentive salience in the sense of visual capture. Let's ignore that. I'm going. The neuroimaging studies in the last 10 years, a number of other people have been showing that there is mesolimbic hyperreactivity in some individuals who are showing compulsive eating, some individuals who are showing compulsive gambling, some individuals who are showing compulsive sex pursuit. That looks a lot like the hyperreactivity of the brain seen in drug addicts. People like Ashley Gearhart here at Michigan, my colleague, has argued that there is such a thing as food addiction, and this kind of hyperreactivity, this sensitized response, could develop spontaneously in some individuals to cause it. Others have argued that people who have really strong sexual addictions, usually young men who are pursuing pornography and masturbation to an extent that interferes with their life and distresses even them greatly, so they come to a psychiatrist and ask for help. These individuals are showing hyperreactivity to sexual cues, and this paper is asking, is excessive sexual behavior an addictive disorder? These authors are suggesting it is based on this kind of evidence. And the same sort of thing has been suggested for gambling, for some individuals who have this hyperlimbic reactivity to gambling. Opposite from addiction, there's a different kind of application of the separation of liking versus wanting, opposite to addiction. For several human clinical conditions, Parkinson's, depressions, and schizophrenia, anhedonia has long been a label applied to those conditions. Anhedonia means loss of pleasure, that there isn't any pleasure. But in the last 10 or 15 years, a number of individuals have been looking more closely and finding that pleasure actually is present. If you give people nice things, nice tasty ice creams and other things, they give good pleasure reactions, but nothing has value in their life, not ice cream, not social rewards, not family. What they have is not necessarily loss of pleasure, but loss of motivational value for those pleasures in life. So it's new phrases like motivational anhedonia or avolition, suggested by these kinds of authors who are studying these conditions, a separation of liking versus wanting. And finally, a desire-dread interaction, the notion that fearful salience can create paranoia, not just in drug users who are taking, say, cocaine or amphetamine and going from euphoria into drug-induced paranoia, that's been known for decades, but maybe even in endogenous schizophrenic paranoia. This is a hypothesis suggested by psychiatrist Kshitij Kapoor and his colleagues, the notion that individuals with this condition have essentially, it's like the Pavlovian fear conditioning with the amygdala laser, an intensified fearful reaction to all kinds of cues in life, so that you and I can walk out on the street and say, see a police car and feel safer conceivably. But a person with this condition can look and see a police car and feel the need, a threat from that police car and a need to weave it in to the delusions of dopamine-powered need. Kapoor suggests that if you take antipsychotic drugs that block dopamine receptors, there's a fast reduction in the motivational compellingness of things like police cars, even if the delusions remain for weeks, but that by reducing the motivational compellingness, by suppressing dopamine of these cues, you give a psychological space that allows recovery from the delusions by separate means. Those are not dopamine mesolimbic mediated. So I'll stop. All I've said really is that rewards, I think whether they're sensory rewards like tastes, foods, or drugs, or even higher level rewards, involve these three kinds of psychological things. We like them, we want them, we know about them. There is a separation in the brain systems of liking and wanting that can be demonstrated for the simple rewards and may well apply to some higher rewards too. They dissociate in a number of these conditions. In particular, addiction may result, long-lasting compulsive addiction may result from sensitization in this mesolimbic wanting system. It only happens in individuals who are especially vulnerable for several reasons. And it can create temptations that are excessively strong. Finally, the circuitry is capable of valence flips, a fascinating phenomenon that we're only beginning to understand the nature of how this can happen and what it means, but I think is a great topic for future research. Very last thing I'll say is, this research, of course, it aims to find out new things about brain mechanisms of liking and wanting, emotion, fear, and motivation. But for me, going back to my years at Penn, the real motivation has also been to find out interesting things about the psychological processes involved. I think we can learn surprising things that like liking and wanting are separable and that can come apart. Things like that fear and desire actually share some psychological as well as neural underpinnings. And so we can get new insights into the nature of psychological processes, as well as insights into their brain mechanisms. And for me, that's been the goal ever since Penn. I will stop sharing my screen. I'll simply say that none of this has been done by me. It's all been done by my colleagues, a vast array of talented colleagues over the year, and I owe them everything. I'm simply a mouthpiece to tell you about it. With this, I'll stop sharing, and thanks.
Great, thank you so much, Kent, for that talk. We have time for questions, and so if you have a question, you're welcome to raise your physical hand, raise your virtual hand, or type your question into the chat, and Harvey and I will do our best to spot you.
There's a hand up, Veda, but your mic is off.
Hi, I just waited to be called. I was really curious about, well, first of all, thank you for your talk. It was one of those rare delights. Really, really enjoyed it. I'm curious about the flipping of the valence in the pain stimulus. So pain is sort of, especially shock, is sort of a peculiar flavor of aversive because it is both startling and pain has sort of a opioid-like component for relief. Do you think it is only possible to do valence flips in these sort of high salient aversive stimulus, or do you think that something like quinine solution or something like that would also work and it's not really about these highly salient aversive stimulus? Any aversive stimulus would do. Thank you.
Well, I think that's an excellent question and an empirical question that we need to find the answer to. And this is just new stuff, so I don't actually have an answer to the quinine. But what I think is, I think the electric shock and the cocaine and the sugar, they all share something. They would have all been good Pavlovian unconditioned stimuli because they all were good affective stimuli. So many unconditioned stimuli were affective stimuli. There's something about the combination of this affective stimulus in the world combined with the amygdala laser that allows these special motivational salience, whether it's going to be desire or fear, to be generated and attached. Do the same brain activation in the absence of this powerful affective stimulus. And there's not really much at all. It's like that's don't care about the laser. Now, whether quinine and other things could substitute for these, that would be, of course, something that we should look at and continue to look at. This is just what we have so far. I don't think, however, that it's opioid relief. I mean, of course, Penn, marvelous place for opponent process theory. And I loved opponent process theory. Richard Solomon, there's still great opponent process theory in addiction neuroscience. But I don't think the rules are working this way. It's not relief. It's an incentive motivation. This is where Bindra is more right than Dick Solomon was for this kind of motivation. It's an incentive mesolimbic. They want it, and they want the cues, and they want to get to it. It's not just about relief.
So I see Amber and Marty. Amber, why don't you ask the first question? Next question.
Sure. Hi, Kent. Thanks for a fantastic talk. I had a question about something that you said in passing. So when you were talking about liking versus wanting, I think this is going to be really important for understanding the basic mechanisms of substance abuse and addiction. And you mentioned that it's really difficult to measure liking of drugs. And so that got me thinking, is there a way that we can measure liking in animals by borrowing the taste reactivity paradigm? So could you, for example, pair a unique flavor or taste to a drug of abuse to actually be able to assess liking, or does taste reactivity not generalize to stimuli that aren't more ingestive or GI in nature?
I think it's a good question. And there are people like Sue Grigson and Gina Corelli who do try to do drug-induced liking reactions using taste reactivity. My own feeling is there is something special about foods and these evolved things. One reason I was attracted to Harvey's lab, even in 1979, is that he had already shown these liking reactions would change with taste aversion conditioning, and he had shown, you know, the brainstem to cerebration independence, and it was something that could have been, it seemed to me, a measure of hedonic impact that could be neat to explore, and that was one thing that was attracted to me. Over the years, we've been mostly restricted to food rewards because we could use it to measure liking. Now, conclusions that come from food reward do seem to apply to other rewards. So for example, the reason I showed you the Marco-Layton cocaine slide with humans is because our conclusion that dopamine mediated taste wanting but not taste liking translated to human dopamine mediating cocaine wanting but not cocaine liking. So the conclusions transferred. It's just difficult to have an animal measure of that conclusion for cocaine directly, I think. It's very frustrating. So we study what we can and conclude and infer applications when we must.
Thanks.
Marty? You're muted. You're muted, Marty. You're muted.
There we go.
Ken, thank you very much. This is splendid work. I've been enchanted by it for years. I think I have one question, but it might be two, and it has to do with the mapping of liking and wanting in your work onto phenomena in humans that I'm more familiar with. So the first part of it is I'm very interested in people who we call low positive affective, widely used term for people who don't seem to experience a lot of pleasure, a lot of liking, but they do experience a great deal of wanting. And I want your analysis of that, but let me tie the second part in, which I think is related. And it's in my own life. From the wanting point of view, what I spend most of my time doing is psychology and bridge. So I want to do both of those things. Neither of them bring me pleasure, hedonically. I'm reluctant to admit it, but there are things I want to do without the pleasure attached. On the other hand, the things that I like, I don't spend a lot of time pursuing. So I like back rubs, meatloaf, Mahler, buttercream frosting, but I don't seem to want them. That is, I don't spend a lot of time at them. So I guess I'm asking for analysis of one or both of those phenomenon. And I think of myself as a low positive affective, by the way.
Well, Marty, I think even if your psychology hasn't brought you much pleasure, it's brought pleasure to other individuals over all these decades. So you can be satisfied with that at least. I think it's the low positives, you know, if they have strong wants and low likes, that's a fascinating phenomenon. And I'm not qualified to say much about it. I'm not qualified to say much about anhedonia either. You know, the people who study anhedonia and say it's not really anhedonia, but really avolition in those clinical cases, or at least in many of those clinical cases, that's an application of the idea, but I don't really, what can I say? I'm interested, but I can't opine about it. I would love to know, you know, more about the clinical diagnosis for those individuals. Now in life, in ordinary life, buttercream frosting is maybe something we don't want much of the time, but there might be certain moments, right? And the wanting, this wanting, again, it's not all wanting, it's this mesolimbic wanting, the kind of wanting that does light up these structures in scanners in people, you know, things like sports cars, things like sex, things like buttercream frosting when you're hungry. Back rubs, I don't know. I don't know if that study's been done in neuroimaging scanners, but if anybody does know, you know, send me the citation. There may be lots of things we like, but not want in this way. This is a mesolimbic wanting. Our desire for world peace is not this kind of wanting. We may want world peace, but I don't think it's going to light up the mesolimbic system. It's a different kind of want. And so there's diversity in these psychological processes. We're just trying to get a handle on this kind, which seems to be really important in some pathologies like addiction and important in buttercream frosting and some things in life, but maybe not in all things in life.
All right, we have a couple of questions from people who mentioned them in the chat. Lindsay, would you like to ask your question?
Yes. Hi, great talk. Oh, sorry, do you hear an echo? Okay.
Yes, we do.
Okay, is it better now?
Yes.
Great. I'm wondering if there's a specific genetic or spatial like subpopulation of these central amygdala neurons that's producing this wanting pain effect.
The wanting what hurts you? Yes, we would love to know that too. And we are trying to map it. So far, we don't find anatomical localization within the central nucleus of the amygdala. We do find anatomical localization to the central nucleus, which is a striatal type structure. The basolateral amygdala, which is a cortical-like structure, does not generate these intense motivations when you stimulate in these ways. So there's something about that. Now, within the central nucleus, there's all kinds of neurons. And we're now looking at special, with Cree lines of rats, we can turn on just the CRF neurons in the central amygdala, which is creating some wants, to the surprise of some people. We can turn on just D1 dopamine receptor neurons in the central amygdala, or just D2 dopamine receptor neurons. There's all these little families of neurons, and we can turn them on one at a time. So we're starting to get a handle on which kinds of neurons in the central nucleus are doing it, but we don't have a finished story on that yet. I can tell you that D1s are very, very potent at making wanting what hurts. CRF neurons can make you want cocaine and sugar. We're not yet certain about whether it's strong enough to make you want what hurts, but CRF is actually famous now as an opponent process mechanism. George Koob is sort of an inheritor of Richard Solomon's theory, but it's not acting as an opponent actually in our hands in most of these structures.
Okay, thank you.
All right, we have another question from Michael. Michael, would you like to ask your question?
Sure, thank you for a fascinating talk. And as a purely human researcher, I was pleased to see I understood most of it. My question is what we know about the interaction between short-term energy status, hunger versus not hunger, and the wanting liking distinction. And I ask in particular because clinically with obesity, and not just with obesity, sometimes in eating disorders as well, there's a real problem with individuals not in an energy need state, not hungry, still experiencing very strong wanting and or liking. And so, yeah, curious about your thoughts on that.
Well, I think ordinarily there's a very tight connection between energy states and wanting and liking for food. I mean, actually, Randy Galstel's critique of Dalbir-Bindra originally, and Randy was at Penn at the time, was saying that his short-term energy state, he had just eaten a turkey and it changed his wanting and liking. So he was saying cues weren't permanent. Physiological state modulates it. And it's not just energy states. If you take a drink, an alcoholic drink, and you're an alcoholic, that may potentiate wanting to drink. So there's many states that change our wanting for these various things. Now, in some clinical conditions, such as you're pointing to, it may well be that the Randy Galstel turkey phenomenon doesn't quite happen. That the person could eat the turkey and yet still want to eat more turkey in a sense. And that is very interesting. There's one classic group of people who are leptin deficient, right? A Pakistani family who have no leptin, who will always want food. You can feed them a full meal and they want more foods, and the foods are very tempting and the cues elicit their mesolimbic responses. That to me is a prototypical food addict. What you're describing could be something in a step in the direction. There may be sort of a gradient of this sort of detachment of the wants from the physiological state.
Yes, and obese individuals tend to be leptin insensitive. So interesting connection there.
Well, thank you all so much.
Thank you so much, Kent. It was a wonderful talk, and thanks for everybody for joining.
Yes, so I invite everyone to join us further for the virtual reception that will take place on GatherTown. I'm pasting a link in the chat right now. You also have it in the Colloquium invite email. But before you disappear, please join me in thanking Kent for a fantastic talk. Thank you, Kent.
Thank you all. Thanks.